So let's start with introducing Monika. So Monika has been an iOS developer for over 8 years and currently works as a senior staff engineer at ChargePoint. She has worked in different kinds of teams, from being the sole iOS developer in a company of 10 to a group of 12 iOS developers. She enjoys taking an idea from rough inception to final production deployment. She still loves coding after so many years and is thankful about that. And we're also thankful for that. So with that, it's all yours, Monika.
Great. I
need to make you.
Yeah, let me share my screen. Oops, sorry. Cancel your screen. Okay. And so it's interesting that in WWDC, it seemed like they kind of sort of didn't talk a lot about Combine. And even with all the published stuff that we were doing before, they sort of made an they're just observable. Or but I don't think Combine goes away. I think they're just trying to make certain things just be de facto, like easier, like less syntax. But definitely, I think async and await, as Peter was mentioning, it also kind of came after Combine, and it was yet another way to deal with the sort of asynchronous, because this, async and await is basically for any sort of like asynchronous operation and making it easier to sort of, get the results and not have to do the sort of the awkward things that we usually do, like with closures. And then I think Peter went kind of through an interesting, so he has an example with this like making bread, and there's different tasks and each of them can be done, asynchronously and at the same time. And then, he kind of was mentioning that it's easy with the old way to end up in a pyramid of doom. And what he means by a pyramid of doom is, when we have like multiple like embedded calls. So we have like load web source, rep resource, and then you get that data resource, and you have to pass it, to the next thing, and then get that result, and then get, and then it just kind of becomes unruly in terms of like, what, when is the final result done? And then for everything, you have to like check, like if there is, if you do actually get the right result and call, if you don't, then you have to kind of pass the error, and then you just go through the next one. And then it just like, it's very hard to read through that code. And he also kind of mentioned that it's not always clear to know which thread a callback is on because of this sort of embedded nature of it. So a lot of times people kind of, get paranoid. So they do their dispatch queue.main.async, but that if you're already in the main thread, that's not a good idea, because you're just kind of doing this thread hopping, which is not good. But again, it kind of back to the, like, it's just not very clear, not easy to manage this. I mean, if you just have one call, not a problem, right? But if you have like many calls, and then the whole closure thing, like sometimes you just want to make a call and get a result. And you're assuming that the return type of that method is what result you want. With the way we've done asynchronous before, it was, before Combine, because Combine kind of lets you also kind of get a result based on, your subscriber, and you can sort of assign things, if you guys remember, or do a sync. But this way, like with await and async, you can actually get the result. You're just kind of telling the system that, it may not happen this second. So, I mean, that's the other thing that he kind of talks about, that for a lot of things, we have asynchronous operations, for most things, that, a lot of iOS also features, you're not guaranteed you're going to have that return right away. So there is either a callback or whatever there. And, it just, this whole methodology makes it easier to handle that. So he has an example, and he goes through kind of like what the, how we would call it. So we have like some async function, right? And then all we have to do is put await in front of it. And then sort of the iOS knows, oh, okay, so you're gonna, we're gonna put this in a thread pool where, things, you're going to be waiting on this, and then we're running other stuff. And then when this becomes available, then you kind of pop back in here and get the result. And then you're not managing any of that. You're just kind of basically saying that you're waiting for this function. And then the other part of it is like this function, whatever it is that you're defining, you have to like say that it's asynchronous. So you put this async after the function name, and then the result, which is string or whatever. So those are the two things that are needed to make this work. And then, I don't know if you guys looked at, running his example, but he has like a very simple, he's just trying to show how you can take a function and it is going to take some time to give you the result. So in this case, like he has this toast bread. So he now puts this async before it would take a closure, but now it doesn't. So, it prints that it's toasting bread, and then he's basically sleeping for 5 seconds. And you notice that, you're putting await here too, because the sleep means that you're going to be paused for a while. So you're just waiting for the results of this. The result is void, but it's just sleeping. And then you return the final result, which is like crispy bread. And it's pretty simple. Like it's easy. You can imagine that toast bread could also be like, you're like making some network call. And when you get the result, you just return that result, right? Rather than yet passing another closure that you're going to call. Now, he says, like, when comparing this code with the completion handling version, we're no longer have to provide a parameter for the trailing closure. So there's no closure here that's being passed. Instead, we're just using this async keyword to indicate that this is an asynchronous function. And then now this function could, specify a return type, which is nice. And he said, when we had the closure, the return type was part of the closure parameter that we had specified. But this makes this whole method much easier to read, because you're like, oh, toast bread returns a string, right? I don't have to go through like, what the closure is returning. And then he says, but this is really, really important, that we don't need to do the dispatch queue async, because, SwiftUI's concurrency model just uses a thread pool and manages these threads for you. So you just know that once, you're awaiting this and, this method is being called, it's being passed on to some thread pool and being managed there. And then he gives similar examples. So he had the slice, where you have like these slices of ingredients, and before, again, it was like a closure, but now it's just returning an array of string. Again, you have this async specify, and here we're just waiting for 1 second and then coming back from that. And so now when we do our make sandwich, here's the thing, because make sandwich already calls these async methods. So it itself will, also specify async. And that's one of the things once you play around with async and await. And anyways, if you call other like async methods, it will tell you if you don't specify that. So here it's like, awaiting for the toast bread, awaiting for slice. And then once it gets these two, then it's printing out the rest of it and then returning. But because it's awaiting for these things, it itself is asynchronous because it's not happening, it's not returning right away after doing whatever operation synchronously that it's doing. And then he was kind of also mentioning that, if you're like have this asynchronous code, how do you like call it from a synchronous context? So you have this task API, which represents a unit of asynchronous work. By wrapping a call to, in the task, you can call it from a synchronous context, like an action handler, like, when you're doing like a button call or whatever, so the system now knows, okay, this is happening, in this is asynchronous work, and, it will wait, and that, it still will, wait to do this before updating anything else, like for instance, in your action handler. Yeah, and then again, kind of saying that, since make sandwich is now a synchronous function, we need to use await. And the compiler is very, like, if you don't do it, you will get an error. I remember I actually did the one Udemy class for this whole async await a while ago. And yeah, so he was going through a bunch of examples, and yeah, if you would forget, it would just return, have a compiler error, and then you have to fix it. Now, one of the things he mentions that, in here, if you await here, right, then it's going to wait until this is done before this gets called. And for things like, where you have like multiple things that depend on the previous result, like I was showing you guys that pyramid of doom, this makes perfect sense because you can't do those things in parallel anyways. But there are times like, in this example that, toasting the bread and slicing the ingredients can happen in parallel. You don't have to wait for one to do the other thing. And then like, how do you actually call these asynchronous functions in parallel? And he gives an example of that. And then this is this async let. Of course, Swift loves the whole let syntax. And now we have async let. So we have like, you can call, have these, variables, calling these different async functions. And, they will happen in parallel. So unlike the one where we were just calling them like this with the let like that, here we're sort of telling the system, you can call these in parallel. And, at the end, whichever one takes the longest, it's not like, one of them won't be done. So when they're all done, then whatever else you did before, you can then do the next part of the, so here it's interesting that, yeah, here this code will be executed immediately. As long as there are enough resources, the system will run these at the same time in parallel. None of these calls will create a suspension point, means that any code that comes after will be executed immediately. So that's the only thing, like it will, like this will happen right away. Because, where before it was like awaiting each one of these. Um, uh, um, we're not waiting on that. And sometimes that is kind of what you want. You just want these things to happen. And later you're going to be using one of these, like, when you're using that particular variable, you would have got the result for it. Which is kind of weird to me. I'm like, okay, I have to like try this in practice. So, if later I'm calling Y, with the await, it kind of made sense that it was suspending until it was done. Here, yeah, it's like, it's all happening at the same time. And if at some point, and he's showing here, if you want to create at some point a suspension point, because you're sort of like you need all three at some point to be done before you do something else, then you could have this await where you pass in these XYZ. And then when you're printing the result, it's going to wait. This print will not happen until this result is produced. And this is the example he gives here. And I think once you put in the context of here, it's interesting and it gets funkier. So here we have async let toasted. So it's going to go and start, toasting the bread asynchronously. And then you have async let slice. It's going to go and do that. And then basically, if I'm going to print what toasted is, and that was the part that initially when I saw, I was like, oh, how's that going to work if I need to do something with that variable that's, being processed? If you need to, that's when you put the await, so, printing this thing, it will like, and it's kind of funky, like you can do it actually, so it will not actually like print this out until like this toasted is ready. And then the same thing, he had the same thing toasted here. Did he have another awaited? But maybe there would be one for sliced, but I don't see it. Oh yeah, there it is, sliced. So then he says, as you can see, it's possible to use await constant at any place in our code, even inside the string interpolation. Using this approach, toast spread and slice will run in parallel. And, at the time that, but this will only be printed out when, the appropriate, like, toasted is ready here. And then, slice is ready. And I think the other, it could get interesting. So yeah, I'm just thinking that probably when you're using it, you have to make sure what the dependency is and how the rest of your code is going to use that. And then he's kind of showing here. So there's this continuous clock. That was another cool thing that you can use to measure the time of, I don't know how many of you guys knew about this or have used it before. So you can actually use continuous clock and measure like an operation here. So here we, you could put it like, and then this await, it's interesting because here we have like, we basically make sandwich is the asynchronous thing. So it's awaiting on that. And then you can also await on the measure until this whole entire thing. So there's this kind of a group of work, once that's done, and it's going to be, it's happening sometime in the future, then you can measure the time for it. And then that time when we print it is going to be how long you took to make the sandwich. So, and then he's saying, yeah, before, because it was like one after another and you had to wait for the previous one, it would take like 7 seconds. But now it's only 5 seconds because they're happening in parallel. And the 5 seconds is basically the one that takes the longest of the two things to do. So it's I mean, the nice thing about it is that the syntax is pretty, it's not as cumbersome as some of the combined stuff. It's reasonably easy to, at least to call it and make your methods be asynchronous. And it's, I do think it does make the code much easier to read through and understand. And of course, the main thing is you have to trust Apple that they're going to do these things good, that when you're actually trusting them to go and run threads and return your results, that they're doing it well. But probably I would trust Apple over a third-party library anyways. So, and I'm sure there were, I don't know right off my head, but there were other third parties that were trying to do something similar to this, but basically now, and here he's like seeing one of the things is like completion handlers and closures are a common way to implement asynchronous behavior. And to this day, they're being used in many of Apple's own APIs. So unlike, and this is what I understand so far, like, with Combine, they did go and change some of their native calls to support Combine, like as we, with network calls, notification center. Here with Async and Await, I haven't seen that with some of the, Apple's own APIs. That would be something to check. But, if you are, at least when even if their stuff is closure based, at least with your stuff, the wrapper around it, then it could be a lot simpler than how it was before. So yeah, so this is kind of like, so if you haven't read through the chapter, it's reasonably short, so you can just kind of read through it anyways. And we kind of went through it right now. So the next chapter, chapter 15, is the cool one because he's gonna actually do a SwiftUI app where we're using Async and Await. And I think that would be really nice to see in action, because this example he gave was a very simple, just easy one just to see how these things get called, and and especially having multiple async methods. But I think it's nice to see it in the context of an actual SwiftUI app to do that. And now that I look, we just have chapter 15, and then we have, chapter 16. So this really, means that we have like, 2 sessions, and maybe we could add another session to just, do another example project. I don't know how people feel. I mean, I do think, even after this, we may want to either do a project or read another, book, or maybe an emphasis on all the new stuff that's happening in iOS 17 with some of the stuff. That would be good too. But we're kind of like almost at the end of the line. So that's kind of good. Any questions, anything? Because I felt like I just talked a lot.
Yeah, I think I have a question, or maybe just an observation that I have used a dispatch group before for
Yes.
concurrent execution. And I
Yes.
see the pain points there, right? Because it's
Yeah.
still more like closure-based approach. Definitely, this seems more interesting. And one thing was very curious to see that when we are doing concurrent calls, like while making a sandwich, we can toast and slice the bread at the same time, right? So slice the ingredients. One thing I don't see in the book mentioning is how do we know when all these concurrent tasks are finished? Because
Yeah, that's the one. Like if you're, kind of like you did mention the whole dispatch group, that at some point, I think, and I have to see another example, but it looked to me like when you're sort of like, when he did his whole async let, and then you can actually await, like you make, by calling that async let, you're letting each of them kind of happen in parallel. Here we go. But then at some point, it's like you're waiting for all of them to finish before you go on to something else, right? So this whole part here, await, where you pass in array all your, all the results of the other calls. I think that is kind of like, when you get here to the print, this, it would have waited until all of this was done. Is that kind of what you were mentioning?
Yeah,
Like,
yeah, that's true. I think that's the way, because then we are combining like three different, like
yes.
these are constant, right? Like toasted, sliced, these are async let constant. You're right. So this is how we can essentially wait for all of them to finish.
And then some parts, like, if like you're dependent on one of these things, then somewhere later in the code, if you need, then, I mean, this part would be good, when you need, it really is a good analogy for, dispatch group, where you need all the stuff to be done before, you do something with them. There's others that, when you can do a wait on that individual result. And then, you're basically now, I think with dispatch group, where its sort of strength is that sometimes you're not necessarily returning a result, right? You're just doing some operation, right? And as long as, you finish that operation and that particular, item in the group, exits, then, as long as they're all have, entered and exited, then you're done. This one seems to me, but we have to just learn. That's why I think this is kind of like scratching the surface. How about it's not necessarily, these async functions are not going to necessarily return some result to me, but they just do something that's asynchronous. And I need to know when this function is done, right? So I don't know if this works well when, the function is not like void result or void return, because then in that case, how do we know, right?
Yeah, that's a good point, because if
I
it's
think
void, then
they really emphasize like, oh, you use this await and async when it is really an actual result that you're getting back, right? Rather than this, method does some asynchronous operations, and then once it's done, you just return, right? Without a particular, it updates something in the system and you don't get an actual result back, which sometimes, we do have that, like with network calls, like we go in, update something in the server, and then, we're sort of, returning from it. And if there's an error, we'll display that or do whatever, but, we don't have an actual result back. And I think in that case, like maybe this doesn't seem as like it could work, but we need to see some more examples. But definitely if you're, you are going and doing some operation and returning a result, then, doing it this way makes a lot of sense, because that's what they're trying to kind of like streamline this, so that you're not using clunky closures and you actually get the result. And there's a way to ever run it in parallel and wait for everything to be returned, all your results.
yeah, I agree. I mean, async await is like is quite powerful. Like I was surprised, especially with this, the one below the section where we can actually use await inside a string, right? Which I didn't know about that earlier. I had like did some research on async await, but yeah, I never knew we could do that. So that's cool.
Yeah.
And it kind of reminds me, like in general, async await reminds me of promise kit.
Yes, that's right. And that's the whole thing, because that whole like pyramid of, if you're returning, if, when, he was showing how we were just going and calling these, where was it? Calling these closures. Let me me show you. So, yeah, there was here that I did wrong. Yeah, so there's the closures, and I think there's one example like this thing, where you call it and then you're, and it just gets so unruly here. And then the main thing is if each of them, you just get the result, but they can take, although in this case, you probably want to await for each one of them and pass the first result to the next one, right? But at least they're not like, embedded like this, where it's, after a while it gets, so with the hope, it is, I am promising you get this result. Now you can pass that result to the next method and you're going to get this other result. And then, so code wise, it looks a lot simpler, but still in the background, the system is calling this asynchronous. And the other thing that's not very clear, but we have to check is, how about when you do some of these things, you get an error, right? Like, in his little sandwich thing, that just takes a bit of time, but you always get returned a result. How about if, you're making network calls, you could get an array of search results, or you could get an error. So how do you manage that in the calls? I'm interested to see, if chapter 16 sort of goes over that, because if you're doing it in a real scenario, that would be the thing. So we shall see. Yeah, here.
Yeah, definitely the pyramid of doom, definitely helps us a lot now with async await, but previously I remember to avoid that we use a lot of dispatch groups.
Oh yeah, and then there's these examples too, like, they're
Nice.
going, you do, async, and then, you're waiting until this thing gets done. So I'm looking forward to seeing the chapter 15 to see a real example, because in my mind, until I see an example, it doesn't always click in anyway. So it'll be good. Are we all good with meeting next week? Because I'm good for next week doing chapter 15.
Yeah, that works. Sounds good.
Okay. Yeah, I think it might be worth it to just do chapter 15 next week and then do chapter 16. We could just, so that, we have enough time to sort of go through it. And yeah. And, I still think, by the time we finish this book, that's a pretty good, we did go through a lot, so it is good.
Thanks to you, Monika.
Thanks to everybody who's showing up and doing this. Any other questions or anything? All right. Okay,
Yeah,
then
if you have questions, we can discuss on Slack.
exactly.
As well, so,
Exactly.
Yeah.
As you guys are looking or other things. Yeah, and I'm very interested, like, once we finish this, because there were some new stuff happening, we can see what's kind of coming next with this whole way of doing asynchronous calls. That could be the next thing. All right. Till later then.
Awesome. Thank you so much. Thank you, Monika. Thank you, folks. And we'll see you next week for chapter 15.
Take care. Bye.
Thanks everyone.
Thank you.